Thank you so much for being here. So we're going to be talking about off-world metaverse and how the technology of the metaverse can actually help us to find solutions to find settlements on Mars. But not only to find settlements on Mars, but also to solve some of the challenges that we currently face in society. And maybe many of us can agree that two of those main challenges are climate change and social unrest or social inequality or polarization in society. So one of the aspects that we can consider when trying to solve those problems is what happens if we think completely out of the box and we try to solve a problem by asking a different question. Therefore, the answer might be different. And that's what Mars offers. That's what an extreme environment offers. To be forced to solve a complete long-term settlement in a way that we have not done on Earth before. So if we actually try to do a proper testing on how we would be providing a self-sufficient large-scale colony in extreme environments like Mars, we will face that first we need to solve the actual physical conditions. And that opportunity comes with an space analog. And in a space analog, we can try to analyze and test, like in MDRS and many other analogs, situations that are very similar to those physical conditions that we will find when we go to Mars. But what happens on the societal point of view? The truth is that it's very difficult or almost impossible to create a large-scale settlement on Earth to simulate how people will live on Mars. And that's where technology comes into play. Because thanks to the technologies associated with the metaverse, as we are going to go over the next few minutes, mainly related to virtual reality or blockchain, we can have a multiplayer environment with thousands of people that are going to be coexisting in that same virtual environment. So somehow we can recreate the conditions that we will have on Mars, but in a safe environment that is completely digital. So if we actually look into VR, that's something that actually allows us to create that immersive experience. And in my team, we have been doing some work in VR in the past. Some of our clients was with Louis Vuitton. So the advantage of virtual reality is that it actually allows a different set of multi-users, no matter where they are located, to be in a highly immersive simulation. That's something that technology is helping us to do. But we were talking that the aspects of that simulation has to come to try to create a digital twin of that future scenario. And how are we going to create something that is realistic, that we know that we are creating today, something that we expect to happen in the future? Well, we need to take some hypotheses. We need to do proposals, but those proposals need to try to be realistic. So for the last few years, we have been working with a multidisciplinary group of experts. Some of them, you see them on the screen. We have members from NASA, professors in astrobiology, sociology, blockchain, and many other fields to try to create a hypothesis. And that hypothesis is, okay, let's create a canvas so people can start experiencing an initial proposal of the entire ecosystem of how we envision a self-sufficient settlement on Mars. That connects to creating the first proposals. And that proposals, as I was saying, is basically going to be an opportunity for all those thousands of players that I was explaining before that can actually start providing feedback. And that is very important because in the digital twin, the advantage is that that digital replica of something that is expected to exist in the future can be bringing feedback and information from the users that allow us to permanently change the digital simulation to adapt to the feedback from the users themselves. So here you can see some visuals of some of those environments that we are envisioning, and you will see a lot of visuals in the next few minutes. I'm not going to be stopping in all of them, but the idea here is that the community becomes the core of the building of the future. Because by creating that initial canvas, the users that can provide relevant data, not only on their feedback, but also on how they interact among themselves, how they're going to be dealing with social unrest and potential challenges that will be happening because of that simulation is going to be according to the harsh environment. What happens when there are no resources? What happens when there's conflict in the society? How are we going to simulate, or how is the group of people going to actually relate to each other when there are problems in governance, when there are a lot of challenges with wealth internally in the ecosystem? Again, we see a lot of those situations happening already on Earth, and they will happen for sure on Mars. So we need to ensure that not only we cover the physical aspects to provide a realistic solution for Mars colonization, but also that we are ready once we have a large-scale settlement, that we have been testing all the potential outcomes of those societies and what potential problems they will face. So the challenge here is, again, first we need to propose what is going to be on Mars. So the hypothesis that we are basing the initial canvas on is that first we are going to arrive with very few humans, scientists, that are going to be living in an area that we are calling Mars Alpha, that is 3D printed buildings that are covered by large canopies. Many of you are well familiar with the challenges of Mars, the extreme exposure to radiation, the potential impact from micrometeorites, the differences in pressure that will cause the buildings to explode. So by having small buildings that are 3D printed and are covered by large canopies, we are able to solve many of those problems. But the truth is that that is not scalable. And what we are proposing on a large scale solution is to go inside the cliffs of Mars. The advantage of a cliff is that by creating tunnels inside the cliff, we are able to provide a highly scalable solution that solves many of those problems that we are all well familiar that happen on Mars. By creating a web of 3D tunnels, we are able to be protected from radiation and potential impact from micrometeorites. The rock will absorb the differences in pressure, but by being in the side of the cliff, we are also being able to capture the indirect light from the sun, which is essential for the well-being. Many of you might be well aware of solutions that are underground on Mars, like in lava tubes or other solutions. But again, we are here considering in the hypothesis that once we grow the settlement, we are going to have permanent citizens living on Mars. So to ensure that we are able to provide environments where not only they can survive, but they can thrive, where the sense of identity and the sense of well-being is guaranteed, is something that is very connected to light. And that's one of the solutions that we are finding that works very well by going inside the cliffs. And you can see, for example, here some views of how it works when we are looking from the outside of the cliff towards the horizons of Mars. But as I was explaining before, the challenge that we will have on Mars is that because it's such a harsh environment, we will need to change the way we consider the organizations in society. And the truth is that in such a hostile environment, we will need to consider that people will have to collaborate to help each other. So living on Mars and guaranteeing a long-term settlement on Mars is going to force those citizens to actually collaborate and to work close to each other. That means that they will probably have to transcend individual interest. In the same way that we might not have two people going to climb the Mount Everest and one of them decides to forget about their partner, and then by doing so, they're putting themselves at risk and their partner at risk. It will happen the same on Mars. So the way that we live is going to be very deeply affected by how we envision that type of life. And here, what you see again in this hypothesis is that by creating neighborhoods inside the tunnels, we can have what we are calling a Martian co-living environment, where by having small areas that you see on the screen in colors, there are small apartments, you will see some images later, but also communal areas that enhance the relationships among the community. That is something that is deeply connected to the possibility of ensuring that those citizens are going to spend time together, and the ties inside the communities are forced because of the way that we are creating the architectural environments for them. You can see here some examples of how we are envisioning the relationship with nature on Mars. Here you can see a view from the hedge between the Martian environments and the inside environments that are in those tunnels that I was explaining. But this is also a great opportunity to bring a relationship with our history from Earth, because the advantage is that we can bring seeds from Earth efficiently, but we also know that the settlement have to be self-sufficient. And that is something that we can definitely get a lot of learning and insights. While on the moon, we can rely on resources from Earth, on Mars, we cannot because of the distance and the orbits. So the entire strategy of a colony or a settlement that is providing a safe environment for large community has to be completely self-sufficient. But we can bring elements from Earth, like plants, to create a linkage with the past that the Martians will have. As I was explaining before, the communal areas we are considering in this hypothesis that are going to be essential to ensure that that colony and that community is able to interact with each other. You can see here the apartments where we think the scalability is going to be essential. Because again, we cannot rely on having things custom-made, considering the lack of resources we have on Mars. But still is a material that we believe, again, working with many diversity of experts that we have been working over the last couple of years, that still is a material we can obtain on Mars easily. There is a lot of iron. We can obtain carbon with combination of CO2 and water. So creating scalable units, those apartments that you see here, the interiors, are 250 square foot each. They are individual apartments. As you can see, they are not very big, but they provide the opportunity for the individual to still have a sense of privacy, while the rest of the environments on the settlements will be mainly co-living environments. What you can see here again is that by asking the question a completely different manner, we need to start giving answers very different. How are we going to work on Mars? Well, the truth is that exercise is going to be essential. And while working, why not providing the opportunity to exercise while we are working? So you can see work pods here that are going to be providing the opportunity for the community to control the robotics and artificial intelligence that are going to be essential for life on Mars. But at the same time, they create a very unique way of approaching the life on Mars that they will definitely need to work. How is the relationship with the transportation and the shopping? Well, as I was saying before, the advantage of the digital twin is that it can allow us to provide great amount of insights of how the users, of how those future Martians that are currently enjoying that life in the digital environment are going to interact with each other. How are they going to shop? How are they going to transport in the different areas of the city? And that can give a lot of data that can be later integrated into machine learning in order to understand social behavior, social sciences. So again, going back to what I was explaining before, while in an space analog, we are able to simulate physical conditions, we still don't have the opportunity to simulate how a large amount of members in a group would interact with each other if we put them under extremely harsh conditions. And that's something that, thanks to technology, is starting to become realistic, and that's what we are doing. So we expect to get a lot of data that could be later provided open source to the scientific community. So again, we can get a lot of information about the social aspects. But how is going to be fashion? Again, we need to start everything from scratch. How is the supply chain on Mars when there is nothing over there? The amount of energy and the amount of resources that we take on Earth because of fashion is astronomical. Fast fashion is one of the main sources for climate change. How are we considering on Mars? Are we going to go on androgen solutions? Are we going, what type of materials are we going to have? Is silk a possibility? What type of solutions are we going to have? Not only to provide the programmatic aspects, or not only to ensure that fashion provides the warmth that they will need, but the sense of identity is going to be essential. And that's where arts and design come into place. It's not only about engineering. It's not only about ensuring that people are going to live and survive. But again, we are considering here in the hypothesis that I was explaining that people are going to live for their entire lives on Mars. And that's something that it's going to happen sooner or later. So how are we facilitating that the relationships among themselves and with the sense of identity is unique, is something that is very important. And we expect to get a lot of feedback through the digital twin that we are building. How is the farming? Well, the truth is that when we were working with a group of scientists, we simulated the amount of space that we needed on Mars to provide the farming for the community. And we came up with a number in the round of 1,000 square foot per person of space or land used for providing the food required for each person on Mars. Well, the truth is that on Earth, we use 60,000 square foot per person on land related to farming and livestock. So that automatically gives us information of things that we could do different on Earth, like reducing the amount of meat intake, performing or enhancing technologies related to farming and hydroponics and aquaponics, and changing the lifestyle that on Mars they will be forced to do, and that on Earth, because Earth is so forgiving and has so many resources, we don't really do it. That connects again with information that the community that is actually experiencing the virtual reality environment will be able to learn by doing. There are many ways that we can learn, and by having a direct experience in a highly immersive manner and seeing what happens if you need to spend a lot of power units, which is how we are calling the internal currency in the ecosystem, which is deeply connected to energy. So if you need to buy a burger, a chicken burger, suddenly it's going to cost 10,000 times more than if you buy a tofu burger. Automatically, the users will start to question why is that. And there are many levels of education that we can get through the actual experience. And that's what we are aiming. We are aiming to combine science with education through gamification, because that's something that, again, when people, especially the younger generations, are able to experience something that is very deeply connected to their actual experience, once they go back to the day-to-day lives, they might be implementing certain changes in their day-to-day lifestyle. And again, diet is one of them that we think is going to be very relevant to learn from. What happens when we analyze the economy? As I was explaining before, the opportunity that we are seeing in the hypothesis that we are proposing is that not only VR provides that immersive opportunity for the community to see how a future could be, but also blockchain allows to simulate an economy, to simulate governance. the opportunity that we have with blockchain is that it's very easy to trace what happens with every transaction, and it's decentralized. So we think that being able to simulate an economy in the virtual ecosystem, that we can see very easily what happens with every transaction, can again provide a lot of information and data that can be relevant to the scientific community, especially when we are looking into the social sciences. And governance. Governance is the architecture of power. And so are we going to have a democracy on Mars? Is it going to be a dictatorship? Is it going to be something completely different than none of us can think of now, but that thanks to this testing and opportunities for a community to provide information, to test things out, to change what works and what doesn't work, maybe we can come up with. So what we are proposing here is an ecosystem that allows for the community to test things up. Maybe together in 4, 5 years, 10 years, we are able to provide solutions on governance that none of us across the history on Earth might have found, that might be a little bit more egalitarian and fair to the community, or maybe not. But again, that's the advantage of the digital environment, that is safe. Even if something doesn't work, we can go back, restart again the ecosystem, and try something else. And that's where we see great opportunity for the users. They're going to become builders of the future, because by creating solutions, interacting with the environment, not only their feedback might be directly implemented into the digital twin of the future scenario, but also they might be able to provide information that later could be actually implemented on Mars. So let's look a little bit more into details on the particular technical aspects. So we are proposing, as I was explaining, an scenario where we have 2 phases. The first phase is implementation of 3D printed buildings with canopies, and then Cliff City, we are calling, where we go inside cliffs. We are proposing this in Tempe Mensa. The advantage of Tempe Mensa is that it has a lot of water, it's close to a former river, and the temperature is quite mild considering the conditions that we have. So you can see here an aerial view of the Tempe Mensa region. But transportation, obviously, is going to be important. We cannot have a large settlement on Mars if we are not able to get there. So working with the logistical aspects of the settlements is going to be very important, and we are proposing some of them. Again, the opportunities that we have with landscaping and creating areas for people to interact with each other in a natural environment that has some type of memories of Earth is something that in the hypothesis of the environments, we are deeply building on. And here you can see some samples of the 3D printed buildings that we are considering on the first phase. So with this, I'm going to show you very quickly a video of a couple of minutes that summarizes a bit more of some of the concepts that I explained, and then I will be taking some of your questions, and then you have my contacts information here in case you want to reach out to me. Let's see if I bring up this video, and hopefully it works. There's no audio. Sorry, guys, there is no audio for some reason. Do you know how to make this work? Okay. There's no audio, so you can take a look at the information at the link that I share. Is a pity because it's quite exciting, but anyhow, again, if you go to the website, you will be able to take a look. And so I tried to explain briefly some of the opportunities that we see on leveraging the power of current technology related to virtual reality and blockchain and digital twins into creating scenarios that we expect that will happen in the future. And we are calling this the Futureverse because while the metaverse usually is connected to environments that don't exist, what we are envisioning in this environment is to create future simulations or simulations of future environments in harsh conditions. Mars is the first step, but we are envisioning many other ones that might be connected not only with the space exploration and the moon, like the moon, but also on Earth. What happens if the ocean goes up in the level of the oceans goes up, and suddenly we need to build cities in floating locations on the oceans, right? So all of these type of situations and scenarios is something we can easily duplicate in the digital environments, and we can have huge amount of data that can provide us insights to solve many of those problems that I started the talk today that we are well aware that we have in the present. So I'm all yours for any potential questions or suggestions or ideas you might have. Yes, sir.
I mentioned this earlier. Is this actually using the platform of the metaverse, or is it a different platform?
Yeah, so the metaverse is a very general concept. So the metaverse is a immersive simulation that people can experience from different locations, mainly through virtual reality. And many companies are now creating together the concept of metaverse. I mean, Meta, formerly known as Facebook, it changed the name and is doing some very, very small part of what the concept of metaverse is. So again, we are using a lot of the technologies associated with some of the experiences that many people are doing in the metaverse to use it for scientific purposes and education purposes by using gamification and design and merging design and technology to create what I just explained. Yes, sir.
Hi. I'm sorry I missed the first like 5-10 minutes of the festival. I assume we've already covered this. The components and the models that you're using inside of the simulation, are these actually like 3D printed like AutoCAD files you could download and you're just dropping them in? Or is this stuff that's like theoretical in design?
Yeah, so the environments that you saw, many of them are physical environments, are a hypothesis that we have created as an first canvas for the community to start interacting with it. But that hypothesis is highly scientific. We have been working, maybe you missed it, with top global experts, more than 30 experts in different fields, from astrobiology, life support systems, planetary geology, some members in NASA, blockchain guys, virtual reality, sociology. So we can ensure that that hypothesis is as real as possible. But again, we know that that will potentially change, not only based on the feedback from the users and the community and the ideas that they might share, but also with time, we might realize that there are things that could be changed or improved or completely altered.
And so the users, do they have the ability to like submit mods to this system as it is?
Yes.
Is that?
Yep.
Okay, perfect.
Yep, exactly.
So this has potential, of course, to generate a ton of data in terms of the users. Can you touch a little bit about what your plans are in terms of the analytics on the back end?
Yeah, so for us, the vision is that all the data that is as a result of the interactions and the feedback from the community is sent back to the scientific community as open source. Again, we see this as a huge opportunity for scientific analysis, mainly in the social sciences, on how the people actually relate to each other and interact with each other and live in an extreme environment simulation like we have on Mars. My pleasure.
Thank you.
Perfect. Very good. Thank you.